Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. As more and more automobile manufacturers have come to place importance on hybrids, a variety of hybrid systems have been developed. This video presents an overview of those systems and attempts to classify them based on their functions. This channel also offers many videos that explain each hybrid system in detail. If you're interested, please check them out. Hybrid systems come in two types: self-charging hybrids and plug-in hybrids. Because the only major differences between these two hybrid systems are battery capacity and whether they can be charged externally, we'll refer to them collectively as hybrids in this video. The first classification is based on whether the vehicle can run using only the electric motor. A system that cannot drive using only the electric motor is called a mild hybrid, while a system that can drive using only the electric motor is called a strong hybrid. Mild hybrids can also be divided into two types: the BSG type and the ISG type. The BSG type hybrid system places an ISG, integrated starter generator, which combines the functions of a traditional ICE, internal combustion engine vehicle's alternator and starter motor, in the position of the alternator. The ISG in this system transmits power via a belt, which is why it is called a BSG, belt-driven ISG. This system is used by many automobile manufacturers, including Volkswagen, BMW, Audi, Volvo, Mazda, Suzuki, and Fiat. When starting the engine, the BSG operates as a starter motor and cranks the engine. During launch and acceleration, the BSG functions as a drive motor to assist the engine. During normal driving, the BSG operates as a generator, supplying electricity to the vehicle's electrical system and charging the battery. Volkswagen, BMW, Audi, and Volvo operate the BSG at 48 volts, Mazda at 24 volts, and Suzuki and Fiat at 12 volts. Since the BSG transmits power through a rubber belt, it cannot handle high torque. A system that places a more powerful electric motor than the BSG between the engine and the transmission is called an ISG-type hybrid system. The system is used by manufacturers such as Mercedes-Benz and BMW. Its operation is similar to that of BSG-type hybrid systems. When starting the engine, the ISG functions as a starter motor. During launch and acceleration, the ISG functions as a drive motor, assisting the engine. During normal driving, the ISG operates as a generator, supplying electricity to the vehicle's electrical system and charging the battery. Let's take a look at the difference in output between the BSG and the ISG. The BSG in the Volkswagen Golf produces 14 kilowatts and 56 Newton-meter. The BMW X3 BSG model delivers 5 kW and 25 Newton-meter. The Volvo XC60 produces 8.5 kW and 29 Newton-meter, while Mazda's 24-volt BSG produces 5.1 kW and 49 Newton-meter. The ISG in the Mercedes-Benz C-Class produces 15 kW and 208 Newton-meter, while the BMW X3 ISG model delivers 13 kW and 200 Newton-meter. It is clear that the ISG-type hybrid has significantly higher torque. Since these systems do not have a device to disengage the engine from the ISG or BSG, they cannot stop the engine and run solely on the electric motor. That used to be the definition of a mild hybrid. However, that definition has begun to change. Citroën, Fiat, and Peugeot, all part of the Stellantis group, and Audi have each developed their own systems that allow electric-only driving using a 48-volt motor by disengaging the engine. The Stellantis system is equipped with an engine disengagement clutch between the engine and the electric motor, and it uses a 6-speed DCT, dual-clutch transmission. From a standstill to low-speed driving, the engine is disengaged by the engine disengagement clutch, and the vehicle runs using only the electric motor. When the vehicle reaches a certain speed, the BSG operates as a starter motor to start the engine. After that, the engine disengagement clutch is engaged, and the vehicle runs on the engine. During acceleration, the motor assists the engine. Audi's system is equipped with an electric motor at the rear end of the 7-speed DCT, and it disengages the motor from the engine by disengaging the two clutches of the DCT. These systems are capable of launching and driving at low speeds using only the electric motor, which deviates from the traditional definition of a mild hybrid. However, each manufacturer refers to this as a mild hybrid. It's a bit confusing. But would the classification diagram look like this? There are three types of strong hybrids: parallel, series, and power split. Parallel systems are mainly used in PHEVs and are only rarely used in self-charging hybrids. This system consists of an engine disengagement clutch, a drive motor, and a transmission. If there is sufficient battery charge, the engine disengagement clutch is disengaged, and the vehicle runs using only the drive motor, just like a battery EV. When the battery charge drops below a certain level, the vehicle operates in hybrid mode. At launch, the engine disengagement clutch is disengaged, and the vehicle runs using only the drive motor. When the vehicle speed exceeds a certain level, the engine disengagement clutch is engaged and the engine is started. During normal driving, the vehicle is powered solely by the engine, while the ISG operates as a generator to charge the battery. Although the speed range for driving on the motor alone varies, this hybrid mode functions similarly to the mild hybrid systems used by Stellantis and Audi. Therefore, Stellantis and Audi's hybrid systems can be described as parallel hybrids powered by a 48-volt system. So, the classification diagram would look like this. Series hybrids are used by manufacturers such as Honda, Nissan, Mitsubishi, and BYD. The engine is dedicated to driving a generator, and the electricity it produces powers the drive motor. The engine and the wheels are not mechanically connected. Because the efficiency of electric motors decreases at high speeds, this system does not deliver good fuel economy on highways. To overcome this weakness, Honda, Mitsubishi, and BYD have equipped their systems with a clutch that directly connects the engine to the differential. By the way, terms like series and parallel that describe types of hybrid systems refer to the flow of energy. In series hybrids, energy flows in a straight path from the engine to the generator, inverter, drive motor, and then to the wheels. In parallel hybrids, there are two parallel flows, one from the engine, transmission, and wheels, and the other from the battery, inverter, drive motor, transmission, and wheels. Honda refers to their system as series parallel type. Mitsubishi also uses terms like series driving and parallel driving. So systems equipped with the direct drive clutch are classified as series parallel types. The power split systems are used by Toyota, Ford, and Subaru. This system consists of an engine, a generator, a planetary gear, and a drive motor. The planetary gear splits and combines the output from the engine and the drive motor, and also functions as a CVT, continuously variable transmission, when the vehicle is driven by the engine. Toyota previously referred to this system as a power split system, but in recent years, they have begun calling it a series parallel system. It's true that it combines series and parallel driving modes. However, it's not entirely accurate to classify Honda's and Toyota's systems as the same series parallel type, as they are fundamentally different. Then, would this way of classifying them be the clearest? What do you think? Although there are now many different types of hybrid systems, technological development is still moving forward. The upcoming Mercedes-Benz CLA will feature a 48-volt mild hybrid system, and some reports suggest it will be able to drive on electric motor power alone at speeds of up to 100 km per hour. Nissan has announced that their next-generation series hybrid system improves highway fuel efficiency by 15% without using a direct drive clutch. It's exciting to think about what kinds of systems might emerge next. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.